So it's a bit disturbing to be introduced as a professional. So I'm not actually a professional because I don't get paid, other than some sort of beer money. And I've only done one cruise, so I'm still very, very much a rookie. Anyway, this is taken from part of my my cruise talk. So why naked Norway? Well, a bit like Lewis and Harris. Norway is amazing because it's over 50% bare rock. And a lot of that's down to the fact that it's quite mountainous and it's been laid bare and exposed by multiple glaciations. So this wonderful photograph is of the Lofoten Islands in the northern Norway. And this looks to me a bit like the Kulin Ridge on Skye, but on steroids. So I'm going to talk a little bit about the Caledonides, the mountain range in Norway, and then I'll actually do glaciers, a little bit on glaciers, and then I'll finish on fjords, and hopefully won't be more than 20 minutes or so. So if we look at Norway itself, it is an extraordinary country. It borders with Sweden and Finland, and also has a short border with Russia. If we look at the distance from north to south, it's about 1,700 or so kilometres. That's as the bird flies, but if you sailed around it, that would be well over 2,000 kilometres. It's also very, very skinny in parts. So I don't know if you can see that, but there you're only 5 miles or 8 kilometres wide, because there's a deep fjord goes in, and there's the border with Sweden. And if you look at it in terms of how it sits within Europe, and you start sort of spinning it around its southern axis, you can take it all the way, almost reaches Greenland, and the southern, if you flip this down to the south, you get down to Rome. So Norway in itself is quite an extraordinary shape, but it's very, very long. But the thing we know about Norway is it's just full of fjords, and it's actually got the second longest coastline in the world in terms of countries. So it's only Canada has a longer coastline than Norway, and the length of the coastline, if you started in the northern part of Norway and then you walked all the way along the coast, holding on to the coast all the way down, you'd go over 57,000 kilometres. So that's way over the circumference of the Earth. So it's extraordinarily fjord rich. So let's have a look at the geology. The geology of Norway can actually feel very, very complicated, but you can simplify it down into some sort of basic elements. So there's the Caledonian or the Caledonides mountains, and then there's basically the basement. So this is the Baltic Shield. This is the undeformed basement. That's Proterozoic and Archean rocks, a bit like Mark was talking about. These are very, very old rocks, going from about 1 billion to almost 2.5, 3 billion years old. And then the Caledonides themselves are a mountain range with nappes, thrusts, and part of this is the Western Gneiss area, and that's been, the basement itself there has been thrust. So you've got basement thrusts here. And what we're going to do is we're going to have a quick look at some geology around Bergen, where we can look at some of the nappes, and then we're going to have a look around Hornelen, where we can see some interesting other geology, and then we'll have a look at a glacier at a place called Olden here. And then we'll talk a little bit about fjords. But let's do some plate tectonics reconstruction first. So if we imagine we're going to actually look at the Earth, we're looking at it from the south now. We're in space, South Pole's down here, and we're looking north. So this is 480 million years ago, about the time, just the beginning of the Ordovician. and northern Scotland and Northern Ireland was somewhere near present-day Rio. And this was a long time before Ali's army were there in Rio in 1978. Norway is a sliver of the Baltic Shield here. That's somewhere near present-day Cape Town. Okay, and then the England is right down near the Falklands. So you can see the Iapetus Ocean, and if we flip forward, and we go forward 20 million years, you can see we're starting to close the Iapetus Ocean. We're developing a subduction zone up against Laurentia, and now we're into the Silurian, and then bang, bang. At the end of the Silurian, the early Devonian, we've got the Iapetus suture, which is, again, Mark's already talked about, and we've got this big, big mountain range, which goes, if we look at it in a little bit more detail, the mountain range goes down between Greenland and Scandinavia. It's got a leg going off into northern Germany and Poland, and then we've got all the way through the British Isles, northern part of the British Isles, and into America and the Appalachians. And there's the current sort of outlines. So this is what it looked like at the beginning of the Devonian. And you can see this Greenland has crashed into a continent-to-continent collision. So when we get continent-to-continent collisions, we've got continental crust, which is thicker and more buoyant than oceanic crust. So we don't get, generally we don't get subduction, but what we do get is mountain building, lots and lots of earthquakes, but these thrust faults. And this is a very simplified west-east cross-section through Norway, around Bergen, and we can see we're building these mountains, and this is the old Baltic basement. So let's go and have a look at some of the lovely rocks around Bergen. And I know some of you have already visited that area, but hopefully there'll be something here of interest. So this is looking at Bergen from space, and what you can see is are these Bergen arcs. And these are actually big naps or thrust sheets. The direction of collision is coming from the west, so this is Greenland crashing into Scandinavia. And if we look at it, this is from the top of one of the 7 hills of Bergen, and there's a nasty big cruise ship. But I wasn't on one of those. I was on a much smaller cruise ship, and you can hardly see my cruise ship, but it's there. Anyway, so I don't like big cruise ships. So the direction of compression is coming from the west, and this is this is the sort of the arc building up around here, and we're actually on the arc on the other side as well. And what do the rocks look like? These are some of the beautiful, beautiful rocks. So this is a bit like Lewisian gneiss. So you've got Lewisian gneiss, but in here you've got this fabulous dark rock, and this is amphibolite. And amphibolite is a sort of a medium-grade metamorphic rock, generally metamorphosing dark mafic rocks, so like basalts or diorites. And it's interesting, the word amphibolite comes from the Greek amphibolus, and that means ambiguous. So I think the amphibolite doesn't really quite know whether it's a metamorphic rock or an igneous rock, maybe. But yeah, so beautiful rocks as well. And now I want to show you an area which is it's not unique in Norway, but it's certainly, you're surrounded by really, really hard rocks, metamorphic, igneous. I didn't mention here's the Oslo Graben, but you've got some granitic rocks down here, igneous rocks, plus some sedimentary rocks. But Hornelen sort of sticks out, and let's have a look at it from space again. So this area here has this sort of like almost like a wafer pastry texture to it, and if we some of the highest sea cliffs in Europe are in this area, Hornland Cliffs. It's part of the same geological formation. And it's an intermontane basin that built up during the time that the Caledonian mountains were forming, the Caledonide Mountains. And here's a picture of the cliffs. These are about 900 meters high. And you have to think about that we're in this regime of just granites, amphibolites, gneisses everywhere. But this is different. It's actually, now we can see it in a little bit more focus here. There's the cliffs there, and we can see these amazing sort of wafer-like structures. And these dark areas, you might think these are just shadows, but these are actually lakes, okay? And it's dipping Devonian rocks. So this is the UK equivalent would be something like the earliest Old Red Sandstone, the alluvial fans building up against the Midland Valley, or that sort of thing. And this is it's the land of the trolls, okay? So this is like a troll or giant staircase. And you see the hiker down here. So these are these dipping rocks, and these are the lakes, and they're sort of connected by these waterfalls. So really stunning scenery. I was really excited by this. And this is what it looks like in detail. So you've got great big lumps of gneiss in there, but it's a coarse conglomerate. And just thinking about sort of modern day analogues, this is now we're up in the Himalayas. This is Dhaulagiri. On the other side of the valley is Annapurna, and so this is a mountain, very very mountainous range. But you're getting a basin, alluvial fans growing up and building up as the Himalayas are forming. And another example would be Death Valley. Again, very arid, but with these wadis and all these alluvial sediments. So that's about the rocks themselves. So we'll have a quick little tour now of I want to talk a little bit about glaciers. So most of you hopefully will recognize that. So glaciers. So this map here is showing you the dark red colours are the number of times that this area has been glaciated just in the last million years. And you can see the outlines here coming down to the UK. So we know that the southern part of the UK was never glaciated, but we know northern Scotland pretty much glaciated. But the Scandinavian area, particularly Norway, multiple glaciations. So this was 8 times in the last million years, probably about 30 times in the last 3 million years. So that's why the whole landscape in Norway is just so glaciated. So now we're going to go further down the fjords from the Hornland area. We're going to go down Nordfjord and end up in a little place called Olden. Now Olden is as far as you can go with the ship, but then you take the bus up and you come up to this area where we look at this particular glacier called Briksdal Breen, and it's a very, very studied and a very well documented glacier. And it's part of the largest onshore glacier, or ice field almost in Europe. So that's part of the Jostedal Breen. And this is what it looks like. There's a nice sort of a turquoise glacial lake, and then you get this ice field up here, about 1,500 meters, and the big Jostedal Breen glacier is at the top. But of course, it hasn't always looked like this. Oops. So this diagram, I just have to do due diligence here, because this was a diagram made for me by our very own Jim, which is very, very useful. There's another one coming up as well. But this is trying to show you what the glacier would have looked like 10,000 years ago, in the previous slide, we just saw the ice field. So this is the icefall area, the ice field summit up here. But by looking at the moraines, we can date those, and we know that the actual glacier was much, much more extensive 10,000 years ago. Again, looking at it from space, we can see, here's the car park at the where all the coaches go. Here's the ice field, and here's the lake. And 10,000 years ago, the ice was always all the way down to the car park. And then receded, 1750, 1869. So like that was the height of the sort of the mini ice age. It was pretty cold there, but there was no lake there, and then basically it's been receding ever since. But here you can see now 1869, there's no lake there, and then 1980, it was coming all the way down. And you remember the first photo I showed you, 2023. We've now just got a little tongue there. But it hasn't always been receding. So we've got these great records. This is going from 1900 through to about 2015. And then we're starting at the front of the ice sheet back in over 120 years ago. And then we chart how it's progressed. The dark blue colours are going when it's going forwards. Red is when it's retreating. And light blue is when it's sort of staying fairly steady. We had a major retreat going from about 1930 to 1950, a bit stable. And then actually it was quite anomalous within Europe because of very, very hard winters and a lot of snow accumulation on the tops. It actually progressed by about 300 or 400 meters. And then since then, we've had retreat. But overall, going back from 1900, it's retreated about 1.2 kilometers. Right, okay, so Mark's wowed us with his technology. So I just wanted to show you what the rock itself was around that area. And it's a gneiss, which we call an algan gneiss, and the algans are these feldspars. And the way they form is because when the metamorphism happens, whether this was probably an earlier granite, when it basically gets metamorphosed into a gneiss, the feldspars themselves don't change. They might get rounded off a bit, but they form the algans, and then all of these other metamorphic, or all these other minerals, they sort of flow around them. So those are called algans. So beautiful example of algan gneiss, and this is another section of it actually and in the field, and you can see it almost looks as though it's a flow structure. Right, last bit now is fjords. Okay, so fjord, the Norwegians, the Norse language has given us quite a few words which we use for our landscapes. Things like beck and dale, they're all, basically all Old Norse words. And fjord means a sort of just place where you go across. And any idea which country has the most fjords in the world? Yes, you're right. Of course, it's Norway. But there are places like obviously Canada, the States, lots and lots of northern Scotland, northwest Scotland. So how do we typify a fjord? So what is a fjord like? So it can be long, it can be deep, it can be steep-sided, okay? And it quite often and very often follows sort of structural lineaments. And thank you again, Jim. Another one of Jim's diagrams. So how does a fjord form? Well, prior to glaciation, you can see the valley bottom doing something like this. And then when the glacier is working towards the sea, it essentially gouges out and goes down below the current, the previous land level, and then forms this sort of the terminal moraine. And then the sea floods back in, and that causes us to have this drowned drowned sea valley, but it's very, very interesting that it had a lot of these fjords have a very, very shallow entrance, and that's quite important. So if we look at again Lisa Fjord, and we look at the entrance to the fjord and where Pulpit Rock is, a real tourist attraction, and we just look at the bathymetric chart, as you get into the fjord at Forsand, the depth of the water is only about 12 metres. So this is very good news because it means that the big ships can't get in there. But the little ones can, and then as you go further down into the fjord, then you're down to the depths are half a kilometre. So quite amazing. And I thought this is quite interesting. If we think about this area around Stavanger and this fjord, here's Stavanger here, and you see all these fjords. So straight, deep, narrow, and let's compare that with the area in England around Plymouth, let's say. I just chose this one. So this is non-glaciated. So I'm comparing now a fjord coast with a ria coast, a ria being a drowned river valley. And so here we've got a wide entrance, shallow water, sinuous tributaries. So I thought it was just quite an interesting comparison. I mean, obviously the bedrock itself is important as well, but quite different a fjord coast against a ria coast. So what are fjords good for? So I've just as I've finished, I've got 3 or 4 things here which fjords are good for. So this is the Troll platform, and it was built in a place called Vats, not far from Stavanger, and it was at the time it was the largest human-made structure to be moved. So it's extraordinarily huge, and the thing is, they built it in the very deep water parts of the fjord, and so that as they built it, they just sunk it. But to get it out of the fjord, you've got to get over the lip, so you've got to jack it all the way up. So I thought it was a quite amazing photo, really, quite scary. Okay, so fjords are a very, very good place to look for sea eagles. So there's over 12,000 breeding pairs in Norway, more than anywhere else in Europe. The reasons for that, obviously, very little population as you go up the coast, and lots of fish. So, and talking about fish, this is a giant cod, skrei. In cod we trust. At the mouth of these fjords, you get a lot of turbulence with the tides. And these giant cod, they come down from the Barents Sea, they swim a long way. These fish can get up to 1.5 meters in length, over 50 kilos in weight. And the Norwegians just love them. So, so Norway is a very good place for fish. And then finally, it's a very good place to hide German battleships. So some of you have already heard this story, but this is the Tirpitz, and from between 1940 and 1944, the Germans the RAF made multiple attempts to sink the battleship in the fjord, but being in a fjord is a very good place to defend. The Navy were also involved, but they couldn't get their mini-subs in to the fjord because of they were able to put submarine nets over the shallow terminal moraine. So between 1940 and 1944, they had these abortive attempts, but then finally they sent 30 Lancasters in 2 squadrons over in November of 1944, and they were successful. They actually managed to sink the Tirpitz in the fjord. Now, what happened then was that the Norwegians were very thankful, and so they sent a piece of the rock, a bulkhead door, back to the RAF. But because there were 2 RAF squadrons involved, one of them nabbed it, and this upset the other squadron. So the other squadron went and stole it back, which then meant the other squadron went and stole it back again, and they cemented it into their bar above the bar. And then the other squadron went and removed the wall. So the Norwegians sent, being peacemakers, they sent another piece. So I thought that was rather good. So the final slide was that the way they destroyed the Tirpitz was they used these tall boy bombs, and these were 12,000-pound, 5-ton bombs, designed by and invented by Barnes-Wallis. And everybody knows Barnes-Wallis as for the bouncing bombs, but he actually also designed the tall boy, which was really a bouncing bomb on the end of a long, basically finned tail. And the Lancasters went up to 18,000 feet and they dropped them down. And I still can't believe how they did it. But if you go on YouTube and you put in sinking of the Tirpitz, there's a remarkable bit of footage of how they did it. So I know it seems a bit sad that we're in the time of peace and joy and goodwill to be talking about bombs, but he did actually design other things. He was an inventor. But the final point is that if you go and see this, the grave of Barnes-Wallis, it's in St Lawrence's churchyard in Effingham, and this is a lovely piece, I think, of Borrowdale Volcanic series green slate. So that's and I think it's a good place to stop. There you are. So a little bit of everything.